1UZ 4Runner project. Quick recap, this is a 1994 Lexus SC400 4-liter V8 and matching A340e transmission. Preparing them to go into a 1987 Toyota 4Runner. And one of the challenges in that is putting a transfer case on the back of this transmission. I'm going to do two versions of this. I'm going to go through real quick and just point out the list of modifications that need to be made, and then I'm going to do it again with quite a bit more detail. So here goes. First thing, you have to take, obviously, you have to take the extension housing off. Take that apart. You have to drill and tap that hole. You have to cut the tone wheel in more or less in half and find a way to attach it. The common way is set screws. In order to get the transfer case adapter bearing oiled as it should, drill a small hole in the end of the output shaft. Here's the T100 transfer case adapter. You have to use the Lexus speed sensor here. In order to do that, you have to open up this hole. You have to drill and tap. Either drill and you can drill and tap a mounting hole, or I've seen people reuse the stock mounting tab there. Either way is fine. And you'll probably find you need to make a spacer for that sensor to maintain a small air gap between the end of that sensor and the tone wheel. And, of course, cut the output shaft down. And that's pretty much it that you have to do. So now I'll go through the one more modification that I did do, and some more detail on the modifications I already talked about. Alright, so let's talk a little bit more about the differences. One of the interesting differences is on the two-wheel drive, on all the Lexus vehicles, the shift linkage runs on this side, the right-hand side of the transmission. And on all the four-wheel drive A340e vehicles, which would be the gear-driven transfer case four-wheel drive, you're talking about Tacomas and 4Runners and T100s. The linkage is over here on the left side. So I didn't want to mess with the geometry of the shifter. And since I was planning to put a shift kit in this transmission anyway, therefore requiring that I remove the valve body, I decided to replace this manual shift shaft with the four-wheel drive version, which has a little bit longer on that side and the threads for that nut on this side versus on this side. I still use, this is still the Lexus speed sensor, or speed range sensor. Fits right on the end of that four-wheel drive shaft, no problem. This lever is off of a 4Runner. I pulled all the shifter linkage and everything off of a 99 4Runner at a junkyard. So that's what that's out of. And like I say, I have that shifter. So assuming that my position front to back in the truck is acceptable, I should be able to just use that shifter assembly in my truck without any modification. I mean, I'm probably going to have to modify the tunnel and make mounts and stuff, but as far as linkage, it should just work, which would be awesome. Time will tell, though, if that actually pans out. Then moving back, here is the extension housing that used to be on that in rear-wheel drive configuration, and so that obviously has to come off. That used to have this speed sensor. That's the output shaft speed sensor that's used for the transmission functions. And on this side is the vehicle speed sensor. That signal goes to the gauge cluster, and then the cluster conditions it and sends it to the ECU for engine use. Why they have to be two separate signals, I really don't understand, but there you are. In rear-wheel drive configuration, they're one and the same. They spin the exact same. They're literally the same tone wheel. This used to be one piece. This spiral gear drove the vehicle speed sensor, and this tone wheel drives the output shaft speed sensor. In a four-wheel drive, that vehicle speed is read off the back of the transfer case here. This is off of a 98 T100, so it actually had an electronic sensor that threaded in here. But my speedometer cable out of my 4Runner will also thread right into there, because I plan to reuse the stock gauge cluster. And that way, the gauge will still read correctly when you're in low range. But the transmission will still shift correctly when you're in low range, because those two shafts are spinning at different speeds. So yeah, step one, of course, is that this shaft has to get cut down. There's probably 6 or 8 inches cut off of there. It used to have quite a bit more splines. It had threads for a nut. That's a 30mm nut. And then a big long snout, so you have to use a deep offset socket to get that nut off. I was able to rent an axle nut socket from AutoZone for free. That was a pretty cool thing, so check that out if you don't want to have to buy a socket. As far as cutting that down, I didn't keep the measurements, so I can't give you a shortcut there, but what I did was I put the adapter, this factory adapter, on the transfer case. I used a straight edge across this surface and then measured down to the bottom of that input coupler, and then I measured from this surface on the transmission. You have to be careful because it's easy to try to measure from in here somewhere, but this protrudes into that adapter, so you have to measure from here, make a mark, hack it off. Cut-off wheel worked fantastic. The next step was the mounting bolts. Let me hold the adapter and the extension housing next to each other. You can see those top 4 bolts are in the same configuration. You're going to reuse those, but the bottoms are different. So let's turn back to the transmission. And clearly see these top 4 bolts. These 2 were what were used in the rear-wheel drive conversion. These 3 will be used in 4-wheel drive. For whatever reason, Toyota and Warner drilled and tapped these outer holes, but they didn't this one. It's clearly cast. It's got the lump to have some extra material to be drilled and tapped, but it just wasn't. I stood the transmission up on its nose, used something to keep the torque converter in, stood it up on end so that the transmission was vertical, and then my drill has a little level built into it, so I marked the center hole, the center of that hole, and drilled as close to vertical as I could. Tapped it for 10 by 1.5 threads, and then the adapter can be bolted on with all 7 bolts. I used a drill bit or something to feel how deep these outer holes were, and I marked off my drill bit to drill about the similar depth. I didn't want to drill it much deeper, but I know that all 3 of these bolts are the same. They're the same bolts, so I assumed the similar depth would be fine, and I did not break through into any passages, and I have plenty. I can tighten that bolt down without bottoming out. So that, just mimicking what's going on these outer holes, worked great. So those 2 modifications will allow the transfer case to physically bolt to the transmission. Let's talk for a second about the transfer case. There's a lot of questions in the 1UZ swapping world about what transfer cases you can use. The challenge is the older gen trucks and Forerunners have the front diff and therefore transfer case output on the right-hand side of the truck. And the newer ones have it on the left-hand side of the truck. Now that means, of course, the transfer case is different, but the adapter is also different. This flange is shaped differently for that different transfer case. So if you have an old gen truck, unless you want to like graft a left-hand drop front diff in there, you can't use that. The older trucks that have this output are almost all A340h transmission transfer case combinations, which means the transfer case is all hydraulically controlled. It's basically another automatic transmission, and it's much more integrated into the transmission. There are coolant or fluid passages and stuff between them. I'm sure it would be possible to retrofit it, possibly, but this is the easy way. The T100 has been documented many times. I understand there's some sort of Hilux surf trim that offers a similar sort of setup in other parts of the world. But I don't know the details on that, but it may be an option for you. Take a look. This adapter, if you spend some time with the parts catalogs, this adapter part number is also used in some 22RE 4-cylinder pickups and Forerunners from the early 90s, and I think even like back to 88 or so. So I think there is a combination with a 4-cylinder and an automatic that would have gotten something like this, an A340F. But as far as I can tell, those trucks have a different part number for this input shaft, which makes me fear that it might have a different spline count. So that you might be able to get the adapter, but you won't get the transfer case. That might solve some of the problems, because if you call a junkyard or look on eBay or whatever, you can buy a transfer case. It generally doesn't come with this adapter. So that might open up some options on getting an adapter, and you may be able to get a transfer case elsewhere. Otherwise, you may have to buy a transmission and transfer case as an assembly just for the housing, which is a bummer. So yeah, that's the deal with that. The next group of modifications is all to do with the speed sensor. This one you can clearly see. Has 4 posts. It's 4 pulse per revolution. The T100s have a 2 pulse per revolution speed sensor there. And the tone wheel has the magnets in the tone wheel. It actually has 2 magnets that spin around that generate a signal. Whereas this one, they're just steel tabs with the magnet in the sensor. All of that means that in order to use the electronics, the control for this transmission, the Lexus controller, you have to use this tone wheel, and you have to use the Lexus sensor. So with that information, I suspect most people would see what needs to be done, but we'll walk through it anyway. Without that vehicle speed sensor, you obviously don't need this anymore, and you can clearly see that, this would have gone on here sort of like that with what I cut out. It clearly doesn't leave any splines for the transfer case. You can't use the whole thing. So you cut it sort of in half. I took some measurements, and I wanted to leave as much material as I could, so I actually cut it in the middle of the gears, and then used a grinder to grind it smooth to give me some more surface area. I've seen it cut smaller. I've seen it cut about like this and left the gears there. However you want to do it, probably all would work just fine. The next challenge comes with when you cut that off. you're losing the splines that drive it from the output shaft. It's a really tight fit. It's a nice tight machined fit there. Some epoxy or even thread locker or like sleeve adhesive might be enough. This doesn't have to drive anything. It's the only resistance on that is inertia and a little bit of magnetic drag from the sensor. But the common modification, and that's what I did, is to drill and tap it for set screw. Again, real tight fit. One might be enough. I didn't want to, even though it can't move very much, I didn't want to push it off center at all. So I have two run opposite sides. I went to the auto parts store and bought two 6mm set screws. They have sort of a tapered point on the end, and as a result I had very little thread engagement into those holes that I drilled and tapped. So I actually ground the ends of the set screws pretty smooth to make sure I had good thread engagement, because this material isn't very thick. I did not tighten it very tight. I didn't want to risk stripping that, and I didn't want to risk deforming it. So I used thread locker between the tone wheel and the shaft, and I used it on both set screws. And I'm relying more on that to hold things together than the torque. And that should be fine. The next modification comes with the sensor. Because the magnet for the sensor is in the sensor body, it is a larger diameter. So in order to get that into the T100 housing, that hole has to be drilled out. I don't remember the size. You can measure it, but you have to open that up. And I think I used a Dremel or something to open it, to offset it a little bit this way, because it's not perfectly centered over that. I don't think it's going to be, it would have been an issue, but I opted to oblong it a little bit, take the material off this side until it was about the right diameter, and then I took a drill bit and rounded it out. It's just what I did. So then you'll put it together, and you'll measure. You'll line it up right with one of the teeth, one of the tabs on the tone wheel, right with that hole, and you'll want to measure the depth between the outside of this surface and that tone wheel. And you want to keep about 1 millimeter or so air gap between the end of the sensor and the teeth on the tone wheel. Boy, this thing's gotten dirty. This is not designed for that sensor, so don't assume that it's going to just work. I discovered that it would have been an interference fit. They would have hit. So I made a little 1/8 inch thick aluminum spacer. It was super simple. I drilled one hole in the material, stuck the sensor through, and then marked off the other hole and traced the rough shape of it. Went after it with cutting and drilling tools, and before long I had a nice little spacer. You can do, when you fit this in there, you can use the stock T100 tab. There's a bolt here with a little tab that comes down and pushes on the back of the sensor. I opted to drill and tap, obviously, for the mounting bolt. Either way works. The next concern comes with the seal. This uses a little O-ring, but because of the spacer, the O-ring now sits sort of in the seam between my spacer and the adapter housing. Now this is it's not only not under pressure, it's not submerged. There's very little fluid behind that. So it shouldn't be too hard to seal it, but I opted to slather it in some anaerobic sealant just to help out. And then obviously had to take it apart anyway. In my test fitting, got a little ahead of myself, but that's okay. That is the bulk of the well-documented modifications. Well, somewhat well-documented. Some of it's really old and dead links and stuff. But there was one other issue that bothered me, and that is the bearing in the adapter. There's a little bearing in here. It's held in with a snap ring. It was pretty notchy, which was kind of weird for how low mileage the T100 was. So I bought a new one. I did not have any luck finding any aftermarket alternative. Had to go right through Toyota. So I bought a new bearing for that. But I was studying how these systems work, and I was concerned about how it gets lubricated. So let's look a little bit at the Lexus setup. Here's the bearing in the output housing of the Lexus. You can see it's shielded on one side, and the shield would have gone towards the transmission. Now, the output shaft, and I was looking at, it shows in the service manuals that there's a fluid passage in the center of the shaft, and there's a hole right about here in the output shaft. And so the fluid would come out behind this collar, which was, of course, one piece with this, and then flow forward because there's a lip behind this that would create a bit of a seal there. And it would push past, you can see there's 4 missing splines in this collar. It would push through those 4 empty splines through there. This bearing rides right on the splines of the shaft, so obviously you'd have plenty of room for fluid to flow underneath past the bearing that way. And then this bearing butts right up against the drive shaft flange, but it has these 2 notches cut in it, so the fluid can get out from the splines into the bearing, where it can pool a little bit. Look at the housing. You can see there's a little recess there that would allow the fluid from the backside to drain out around the outer race down into this extension housing. Probably no coincidence that it would go right on top of the speedometer gear there. And then there's a groove right here that would allow the fluid then to drain down into the transmission pan. Now when we look at the four-wheel drive setup, this bearing, again, you can see it's got a recess in the corner there. So clearly it's supposed to get fluid, but it has this thing on the front. Let's get this bit of an angle here. You can see how it sticks forward and has a lip on it. It has a little rubber seal that seals it to the outer race. And in the parts catalog, this is referred to as a receiver. And when I started looking, the input shaft coupler thing here on the transfer case has a hole in the side, and you can see where the bearing used to ride. It's just in front of where that bearing is. So the fluid is supposed to come out through the center of the shaft, then out through that hole into that receiver and supply some fluid to that bearing. And I think this frequently gets overlooked. So what I did is I was running the engine on the stand anyway, so I put it in gear so this shaft was spinning. First I marked the center and marked and punched the center of the shaft. Started it, ran it in gear so that this shaft was spinning, and then drilled a hole in it. And that is sort of makes it a rudimentary lathe, and to help get that hole as close to straight as possible. And I only had to drill a ½ inch or so deep into that before I broke through into a fluid passage. The other advantage of doing that with it running is it put a little bit of fluid pressure behind that. There's not a ton of pressure in that. It really is only designed to provide a little fluid to the bearings. It's not under hydraulic pressure, but nonetheless, there was still a little bit of flow that came out through my drill bit, and then when I took the drill bit out, I let it run for a while and flushed some fresh fluid through there. So any shavings from the drilling would push out instead of winding up in the transmission somewhere. And it's only an 1/8 inch hole. It's a pretty small hole, which is actually quite a bit bigger than the one that was on the side, but I was a little concerned about using too small of a drill bit. And that just provides a little bit of fluid to that bearing to keep it clean and lubricated. And I think that's pretty crucial and probably pretty frequently overlooked. So with the new setup, the only other modification is the new setup. This speed sensor is now relocated to the other side, so I'm going to have to extend those wires. I'm leaving these in here for the speed sensor because I may go to a different gauge cluster setup in the future, in which case I may want to use an electronic sensor. So I'm leaving that there. I think that's the only unused thing that I left in the wiring harness. So that's not the end of the world. For anybody that's curious, I'm making transmission cooler lines. These are 16 by 1.5 threads, and I was able to find a couple of tube nuts, brand new tubing nuts in that size. So I'll be able to use standard 3/8 tube to make a couple of lines, new lines, because the old ones are in pretty rough shape. Also, to anyone who's curious, that's the VIN of my donor car. So in the US anyway, if you bought a donor engine and you don't know what it's from, you're gonna have a VIN there, and there's a VIN up here underneath the block heater. That's also the VIN for my vehicle. So that may help you immensely sourcing parts and stuff. It's having the VIN for your donor. Well, that's it. Thanks for watching. And if you're interested in this project, keep an eye out. I'll try to document the oddball things that I encounter as I go.